In the last video, we got basic PWM working. However, in order to do something interesting with PWM, for instance, to gradually fade in or out an LED or increase the speed of a motor, we need to regularly update our duty cycle. We're going to do that in this video, looking at using a second timer. We're going to use the 8-bit timer counter 0, which we found out in one of the previous videos can count up to about 30 milliseconds if we use the maximum prescaler. So that's what we're going to do. We can go straight to the register description because we know pretty much how this timer works. And looking at the waveform modes, we know that we want to use C2C mode. We're going to set output compare register A as the top of the counter, and so we need to set this bit, and we can see that this bit is in timer counter register 0A. So the function we're writing is void millisecond timer, which we'll take in a uint 8, which represents milliseconds, and timer counter register 0A, and the bit we wanted to set was WGM01. Okay, next step, going back to the data sheet, we know we wanted the maximum prescaler of 1024, so we need to set bit CS02 and CS00. And we can see that those are in timer counter register 0B. So that sets prescaler of 1024, and the previous one set to CTC mode. So I have prepared, based on the equation of how we calculate the timer counter frequency, I have prepared some equations, to some calculations, so that effectively a millisecond timer is based on this simple equation here. It's kind of a constant scale factor of 7.8. So the output compare register 0A is going to be assigned to this equation. And the last thing we need to do is enable our interrupt. So our interrupt mask register and its output compare interrupt 1A. Okay, so we should be able to therefore call this millisecond timer, and let's call it 2. Remember, our resolution of our timer is 800. If we wait 2 milliseconds before we increment each, that means we should have about 1.6 seconds before reaching the top. And so what we'll do is now in the timer counter interrupt routine, which we're going to write 0 compare A vector, is we want to write some logic to increase the duty cycle. So remember, it was a 16-bit timer before, so our period was set with output compare register 1A, that represents our period, and our duty was represented by output compare register 1B. So what we want to do is, if duty is less than period, we want to increase our duty cycle. Otherwise, we want to set it to 0, so we turn the LED off again before we gradually start brightening it again. So the duty then output compare register 1B then gets updated with the new duty. Okay, let's test and see if this works. And we can see that the LED is gradually increasing in brightness. So we got some basic functionality of the PWM working, increasing the brightness of an LED. But what we'd like to do is maybe give you a few more options how to brighten or dim the LED, and that's what we'll look at in the next video.